Hi students, this is Mr. Yao. Today we are going to learn the second lesson of inequality story problems. This time we're going to deal with a more complicated questions, and then we're going to actually have to completely solve them. Example 1. A bicycle shop rents bicycles for $2.50 per hour and helmets for $5 per day. Martin has $23 to spend to rent a helmet and a bicycle for 8 hours. How many hours can Martin at most rent a bike for? First, let's understand the question. $5 per day that is not counted by the hour is a one-time fee that you have to pay. So it's just a 5. And then on top of that, you're going to need to pay by the hour, which is $2.50 per hour. So we're going to use $2.50 times the 8. The question said at most rent a bike for. At most means it can not go over that. Besides, if it's a budget, that means you don't have any extra money. You don't have $24. So it has to be less than or equal to 23. We're going to solve that. Subtract 5 over 2.5h is less than or equal to 18. Divide both sides by a 2.5. We're just dividing by a positive number, so we don't need to flip the sign. So h is less than or equal to 7.2. And you can see for all of these examples, there's a setup. There's the inequality, solve, and conclusion. Solve is to get an answer for the inequality. Conclusion is based on the specific question and this answer from the inequality, you're going to need to draw a conclusion to answer the actual question, which is going to be a little bit different. Now, we said h is less than or equal to 7.2. Let's think about it. If you rent a bike, you can't exactly go in and say, oh, I'm going to rent the bike for 2 hours and 20 minutes. That doesn't work. It doesn't work that way. You have to rent for the whole hour. Even if you bring the bike, let's say you rent it for 2 hours and you brought it back 2 hours and 25 minutes later, you're going to have to pay for that extra hour. Actually, so in this case, we have to use a whole number. h is less than or equal to 7.2. The whole number that would actually make this work, which means a whole number that is smaller than 7.2, is going to be 7. So Martin can at most rent for 7 hours. And some of you might be like, oh yeah, that totally makes sense because 7.2 round to 7. Not exactly. Let's say you got an answer h is less than or equal to 7.8. Well, if you say it's going to be 8 hours, my question is, for that extra 0.2 hours, where is Martin going to have the money to pay for that? Right? Martin only has $23. There's no way he can pay more than that, which is why even if it's h is less than or equal to 7.8, it still needs to be concluded as 7 hours. Another way to think about this is you're trying to find a number that actually makes this inequality true. If you say it's going to be 8, well, is 8 actually less than or equal to 7.8? The answer is no. So it has to be a 7. There you go. That's example 1. Example 2. Construction workers are making rectangular fences for a park. The width must be 430 meters, and they have material to make at most 2,500 4.3 meter of fences. So let's look at the question. Put rectangular fences for a park means you are going to put fences around the park, not exactly like in the middle of the park, which means you're actually calculating the perimeter of a rectangle, and that is going to be 2 length plus 2 width. Length is the one we're solving for, so 2 out is going to stay. Width is 430, so it's plus 2 times 430. At most means it can't go over. This is the amount of material that you actually have. So it's less than or equal to 2,500, 4.3. You're going to subtract the 860 over, and then divide the answer by 2. So it's going to be less than or equal to 822.15. Now the question already said you have to keep the whole number. So the length could at most be, you need a number that is less than or equal to 822.15, but it has to be a whole number. So 822 meters. There you go. That's example 2. You can pause here and try example 3 and example 4. They're very similar to example 1. Now let's have a look at example 3. Charles is saving $5 each week. 1 week he earns an extra $15 by mowing his neighbor's lawn. He wants to save at least $75, write an inequality to present the situation. Before you even answer the last question, we're going to need to write an inequality to present. So 5 is by the week, 15 is just a one-time thing, so it's 15 plus 5w at least means greater than or equal to 75. Like the least amount you want is 75, so it has to be greater than or equal to. Subtract 15 over 5w is greater than or equal to 60 divided by 5. W is greater than or equal to 12. Question is, will he reach his goal in 14 weeks? Well, greater than or equal to 12 means even when it's 12 weeks, he already reached his goal. So of course, 14 weeks, he's going to. So he will reach his goal in 14 weeks. There you go. That's example 3. Moving on, example 4. Mr. Yao is saving up to buy an antique camera that costs $720. So far, he has saved $275. He would like to buy the camera 4 weeks from now. What is the minimum amount of money he must save every week to have enough money to purchase the camera? Okay, let's see. 275, I already have it. So that's not counted by the week. But then 4 weeks, and we're saving by the week, so we can still use 4w. Must be able to pay for that camera. So the minimum amount of money, which means has a minimum value of, which means I have to save at least a 720. So it's greater than or equal to. Subtract it over, subtract 275 over, divided by 4. After you finish solving, w should be greater than or equal to 111.25. And some of you might be like, well, for the previous examples, we haven't rounded to whole numbers, so let's do the same. However, let's think about it. 111.25, well, can I actually choose to save $111 and also put an extra quarter? Of course, because money works that way. That's totally fine. I can choose to save a quarter each week. So in this case, there's no rounding we need to do. We can actually use this 111.25. It's only when, say, you got an answer 111.254. Well, you need a number that is greater than that, because if you say, oh, well, I'm just going to save 1/4, I actually won't have enough. I'm a few cents short, and I can't exactly pay for it then. So in that case, you actually still need to round up to be 111.26, but you can still do the 2 decimal places. So he must save $111.25 every week to have enough. There you go. That's example 4. Moving on, example 5. At Hogo Zoo, you can either pay $22.75 for the entrance fee or $71 for the yearly pass, which entitles you to unlimited admissions. At most, how many times can you enter the zoo for the $22.75 entrance fee before spending more than the cost of a yearly membership? This is a slightly tricky question because there are 2 different inequality phrases. One is at most, the other is more than. You might be like, well, which one do I choose to celebrate inequality? Let's see. First, let's say you focus on the word at most. $22.75 per visit. So I'm going to do $22.75 times V, since V is the visit. And that is, at most means it can't go over that, so it's less than or equal to 75. And you divide both sides by 22.75. V is less than or equal to 3.12. Okay. Now let's say you actually choose to focus on the other phrase, which says more than. That would be 22.75 V, that is greater than 71. Well, the issue is, even though the numbers are exactly the same, these are 2 complete opposite inequalities. So divide both sides by 22.75, you're going to get V is greater than 3.12. Well, that's an issue, right? Like they're completely different. Then how do we actually solve it? Well, let's actually continue with each of the inequalities. Let's say you chose to focus on the at most. You can't exactly do a 0.12 visit. What are you going to do? Like go in the gate and then right after come out? Like there's no way. It doesn't work that way. So it has to be a whole number for visits. So if that's the case, you're going to conclude that it's going to be 3 visits. But if you actually choose to use the other one, it seems v greater than 3.12, you're going to have to conclude 4 visits. It seems that the answers are different. However, there's something very tricky about this question. At most, there's no other words for that, but for the more than, it says before spending more than. Which means if you actually made 4 visits, you already spent more than the cost of your yearly membership. So before that, it would still be 3 visits. So for this question, you can set up the inequality either way, using either phrase. But no matter what, your conclusion is a bit tricky. You have to think a bit extra, and the conclusion is going to be 3 visits. So 3 visits before spending more. There you go. That's example 5. Example 6. More than 450 students went on a field trip. 10 buses were filled and 5 students traveled in the car. Write an inequality to represent the situation and find the minimum number of people on each bus. This is about buses, and it's 10 buses, so 10b. And the extra students, the 5 students traveling in the car, is not exactly that they got on the bus first and they got kicked out of the bus then to travel in the car. They just chose to travel in the car. And we're trying to represent the total amount of students. So in this case, 10b, and we're going to add the 5 since we're calculating the total amount of students. Minimum number of people, minimum value of, so it has to be greater than or equal to 450. Let's solve it. Minus 5 divided by 10. B is greater than or equal to 44.5. Well, for sure, you can't exactly keep a 0.5. What are you going to do? 44.5 people. Someone only half of their body can come on, the other half has to hang outside the bus door. That's just not going to work, right? So there's no way it's 44.5. Then now the debate is it 44 or 45? Some of you might feel like it's 44. Well, that also doesn't work because first, 44 does not satisfy this inequality. Second, if you actually only have 44 students, you're going to have a few students being left. What are you going to do with them? Are they going to run after the bus? That also wouldn't work, which is why you have to put a bit more than that. So the conclusion would be 45. So the minimum number of people on each bus is 45. There you go. That's example 6. And that is everything for the second inequality story problem lesson. Thank you.